Okay, this is for Algebra 2, and this is our second day of asymptotes. We're going to focus on horizontal asymptotes, but let's kind of do a quick review on vertical. How is the vertical asymptote used to determine the domain? The domain cannot be whatever your vertical asymptote is. So if your vertical asymptote is x equal 5, your domain is x is not equal to 5. So if I were looking at this problem, I would want to know what the vertical asymptote is. You take the denominator, x minus 1, you set it equal to 0, you solve for x. So I add 1, and my vertical asymptote is x equal 1. This means that my domain is x is not equal to 1. So taking this one for the same problem, so we'll skip it. So looking at this one. For the vertical asymptote, you're going to take x squared minus 16 equals 0. Anytime you have an x squared, I would put it in your calculator at y equal. I would go to my table, and I would find where y is 0. You ought to have two answers when you're talking about x squared. If you do that, you'll figure out that your vertical asymptote, x is equal to 4, x is equal to negative 4. This means that your domain is x is not equal to 4, and x is not equal to negative 4. So if you take this one, once again, we only care about the bottom. So that would be x squared minus 7x plus 10 equals 0. Go to your table, or factor it if you want. It doesn't matter to me. You're going to figure out that your vertical asymptote, x is equal to 5 and x is equal to 2. Meaning your domain is x is not equal to 5, x is not equal to 2. Okay, so now let's talk about the trick for finding horizontal asymptotes. Unfortunately, it's not quite as easy as the vertical. First thing you have to do is look at the exponents, and we're talking about the top and the bottom of your fraction. Okay? Find the greatest exponent ever used in the numerator and the greatest one ever used in the denominator. Okay? When you've done that, what you have found is called the degree of each part of the fraction. If the degree of the numerator is bigger, then there is no horizontal asymptote. If they are the same, then you're going to find your horizontal asymptote at the leading coefficient of the numerator over the leading coefficient of the denominator. Leading coefficient means the coefficient for the variable with the biggest exponent. Makes more sense when you see an actual problem, so hang with me. If the degree of the denominator is greater, then your horizontal asymptote is always going to be y equals 0. So, numerator's bigger, there's not one. Denominator's bigger, it's at y equals 0. If they're the same, you got to make a fraction. So, the degree for the numerator is 2. The degree for the denominator here is also 2. They're the same. That means you take your leading coefficients, which is going to be 3 over 5. So, y equal 3/5 is what your horizontal asymptote is. Degree of the numerator is 2. Degree of the denominator is 1. The numerator is greater, therefore there is no horizontal asymptote. Degree of the numerator is 1. Degree of the denominator is 2. Denominator is greater, therefore your horizontal asymptote is at y equals 0. Degree of the numerator is 3. Degree of the denominator is 3. They're the same, so you've got to make your fraction. It's going to be 4 over 2, which reduces to y equal 2. So looking at this one, degree of the top, or the numerator, is 1. Degree of the bottom, or denominator, is 1. They're the same, so you've got to take your leading coefficient. Y is equal to 1 over 1, because they both had a coefficient of 1, so 1. Y equals 1 is your horizontal asymptote. Degree of the numerator is 2. Degree of the denominator is 1. Since the degree of the numerator is greater, there is none. No horizontal asymptote. Oh, what's the degree of your numerator here? If there is no x, it's going to be a degree of 0. A degree of 1 for the bottom. That means the denominator is greater, so y equals 0 is your horizontal asymptote. Okay, that should take us to the assignment, I believe. If you have any questions about horizontal asymptotes, come see me during speed.